Welcome my dear learners for this course on operations research. In our module 4, we will be discussing on network analysis and queuing theory. Coming for the first topic of our module 4, that is network analysis. The network analysis is predominantly used in project management. A network is a pictorial representation of a project involving various activities and also representing the activity durations. Under network analysis, the two major network techniques which we are going to study in this module are critical path method and project evaluation and review technique, which are shortened as CPM stands for critical path method and PERT stands for project evaluation and review technique. Both of these network analysis techniques were invented by Americans. The project evaluation and review technique PERT was developed by US Navy during 1950s, and also the critical path method was developed by Walker, who belongs to DuPont Company of United States of America. Coming for the network, why it is required in project management. Let us consider an example of construction of a building. If I want to construct the wall of a building, before that I should construct the foundation of that building. Without constructing the foundation, I cannot construct the wall of that building. And also the construction of building involves many activities such as procuring the raw materials, arranging the labors, etc. Like I explained, these activities are interrelated. Few of the activities are independent of other activities and few of the activities are dependent on other activities. Like I mentioned, while digging the earth for foundation, we can procure the raw materials required for the construction of building, because digging the earth for laying down the foundation is independent of procuring the raw materials. But whereas constructing the wall of the building is depending on the laying down the foundation. So therefore, the precedent for the construction of wall of the building is the laying down the foundation of that building. So like that, if I have a very huge project, then the number of activities are more. This might lead to confusions and very difficult to handle the project. In order to simplify the handling of project, we can use this network analysis technique. Under network analysis of this module, we will be studying two important network analysis techniques. They are CPM, critical path method, and PERT, project evaluation and review technique. The basic steps involved in these network techniques are: the first step in network analysis or in PERT and CPM is planning, and the second step is scheduling, and the third and final step is controlling. In the first step of network analysis, that is planning, in the planning stage we will divide the huge project into n number of small projects, and also we will divide these projects into small activities. Coming for the second stage, that is scheduling, in the second stage we will analyze the order of the activities and also starting and ending times of the each activities. And in the final stage, that is controlling stage, we can inspect the progress of the project at any time, and also the management decisions such as upgrading the project or allocation of raw materials to certain activities, etc. can be taken. Next, moving on to the basic terms in the network analysis. First one is network, second one is activity, and third one is event. Let us consider a project involving various activities which is represented by a network. So this is a network representing various activities such as A, B, C, D, E, F, G, H, I, J and K. So a network is a pictorial representation of a project involving activities and events, and also we should represent the activity duration. And activity is nothing but a job which requires resource and time duration. The alphabets from A to K which are used represent the various activities. These activities requires resource and time duration. Coming for the last basic term, that is event. An event is nothing but a node which gives us the time specifying of an activity. That is, it specifies the time duration of completion of an activity or beginning of any activities. These numbers 1, 2, 3, 4 till 9 which I have marked in this network represents the event or node. Hope the basic terms network, activity and event are clear for you people. Coming for the activity are further classified into predecessor activity, successor activity and dummy activity. Coming for the first one, that is predecessor activity. These are the activities which must be completed before the starting of any other activities. For example, the activity A must be completed before the starting of activity B and C. So therefore activity A is a predecessor activity for activity B and activity C. Coming for the successor activity, these are the activities which will start once the predecessor activities are completed. In this same network, activity B and C are successor activities for activity A. Activity A is a predecessor activity and activity B and activity C are successor activities. Coming for dummy activity, a dummy activity is an activity which does not require any resource or time. These activities are used only to complete the network. If there are any discontinuities in the network, in order to complete the network, we will use this dummy activity. The dummy activity are represented with the dashed lines. These activities are used only to complete the network. And one more category of activity is concurrent activities. As name itself indicate, these are the activities which can take place simultaneously. That is, activity B and activity C are concurrent to each other. They can take place simultaneously. That is, as I explained in the beginning of this lecture, that is, in the project of constructing a building, the example for concurrent activities are digging the earth for foundation and simultaneously procuring the raw materials. So digging the earth for foundation and procuring the raw materials are termed as concurrent activities. Coming for the events, we have further classification of events as first one is merge event, second one is burst event, and third one is merge and burst event. Coming for the first event, that is merge event, these are the events for which more than one activity are coming in. In this network, event 9 is an example for merge event, because for this event 9, 3 activities are coming in. That is activity I, activity J and activity K. Coming for the second event, that is burst event, as the name itself indicate from these events more than one activity will move out. If I consider event 2, we can observe activity B and activity C are moving out of it. So therefore, event 2 can be categorized as burst event. And coming for the last one, that is merge and burst event, as the name itself indicates, it consisting of both merging and bursting. If you observe in this network, event 5 is an example for merge and burst event, because activity E and D are merging, whereas activity F, G, H are bursting. So therefore, event 5 is a very good example for merge and burst event. This is the further classification of activities and events. Next, moving on for the difference between CPM and PERT. This CPM and PERT are almost similar to each other with a minor difference which we will be discussing in detail in further classes. Coming for the basic difference between CPM and PERT are: the CPM emphasizes on activities, whereas PERT emphasizes on events. CPM is used in construction and business projects, whereas PERT is used in research and development activities. That is, critical path method is used in business and construction projects, whereas PERT is used in research and development activities. With respect to time, critical path method is deterministic, whereas PERT is probabilistic. What I mean to say is that if I use critical path method, I can determine at what time I can complete a project, whereas in case of project evaluation and review technique, we can say the probability of success or failure within the given time duration. That is, with respect to time, CPM is deterministic. The next difference is CPM is used in non-repetitive jobs and preferably for small projects, whereas PERT is used in repetitive jobs and it is employed for big projects. That is, CPM is used in non-repetitive jobs whereas PERT is used in repetitive jobs, which is nothing but activity. Coming for the final difference which I stated, CPM is used for both big and small projects, preferably for small projects, whereas PERT is used for big projects. Moving on to the next topic, that is Fulkerson rule for numbering the events. Coming for the Fulkerson's rule for numbering the events, the first rule states that event number should be unique, which means that no two events should have common numbering. Coming for the second rule, event numbering should be done from left to right in a sequence. The third rule states that the event to which there is no incoming activity is termed as event number 1. That is the beginning of the network. So for event 1, there are no any incoming activities. So therefore, the event to which there is no incoming activity is numbered as 1. The next Fulkerson rule states that the number of the head node should be higher than the tail node. So if I consider an activity, let us say the activity is X, then the head node should have higher number compared to the tail node. So this is the tail node and this is the head node. Next, Fulkerson's rule states that head node number or head event number should be higher than tail event or node number. And the last rule states that number all new events with 2, 3, 4, etc. until we reach the final activity, which gives us the final node or event. This is about the Fulkerson's rule for numbering the events or nodes. With this very brief introduction to the network analysis, let us move on and practice some network construction problems in today's class. The first problem of our discussion on construction of network states that an assembly is to be made from two parts X and Y. Both parts need to be worked on a lathe before being assembled. The sequence of activity along with their predecessors is given below. Construct the network. We have activities and their respective predecessors. Now, coming for activity A, we don't have any predecessor. So therefore, just now we have discussed about Fulkerson's rule for numbering the event. If there are no incoming activity for a node or an event, that will become the initial or first node or event. So there are no activity coming in for activity A. So therefore, let us number it with 1. In a single go, it is very difficult to construct the network. So therefore, let us use number of trials and approach the final network required for the given problem. That is, moving for the trial 1, as no activity is coming in for activity A, let us have event 1, 2, event 2 is nothing but activity A. Now for activity B, we have predecessor as activity A, and also for activity C, the predecessor is same, that is activity A itself. So therefore, from activity A, we have two activities B and C. Since we have two activities from activity A, that is activity B and activity C. So as per the Fulkerson's rule for numbering the event, the next head node for activity B will become 3, whereas tail node is 2, 1 less than head node. And for C, we have 4. Next, moving on for activity D. Activity D is emerging from activity B, whereas activity E is emerging from activity C. So therefore, From activity B, we have activity D coming out of it. So therefore, we have one more activity D, and the event will be 5. Activity E is coming from activity C. So therefore, after C, we have activity E. This is event number 6. Now, activity F is emerging from activity E. So from activity E, we have activity F. This will become node number 7. Next, moving on for activity G, it will emerge from the activities D and F, which means that these two activities must merge at a common event. So therefore, I should have one merge event. Since activity G is emerging from activity D and F, so activity D and F should reach a merge event. So therefore, I should merge these two activities to a common event. So moving for trial 2, node number 4 we have done correctly. So therefore, write down till node number 4. Now, as just now we concluded that activity D and F should reach a merge event. So therefore, let us mark activity E, no problem, which is now it will become as 5. Activity D and F should reach a merge event. So mark that merge event as 6. From that merge event 6, that is the merging of activity D and F, we have activity G. So therefore, from here we have activity G. So event will become 7. And finally, activity H is emerging from activity G. So therefore, one more activity is emerging from activity G, that is activity H. This completes the required network. In the final stage, you construct the network such a way that it looks nice. That is, the final network will be 1 to 2. We have activity A, we have activity B to event 3. Here we have 2 activities. One is activity C to event 4, and also activity E to event 5. Now these two will be joining for a merge event. This is activity D, and we have activity F. We have merge event 6. And next we have activity G, and finally we have activity H. So this completes the network for the given problem. That's all from this introductory lecture. Thank you.